The other consequence of the mean value theorem comes from if you have two functions. Those two functions are going to be referred to as f and g. So here's the first one. If f prime of x is equal to g prime of x, that is to say, if the derivative of two separate functions are equal to each other, then it will be true that f of x is simply going to be equal to g of x plus some constant. Similar to what we saw in the last video, once you determine that the derivatives are equal to each other, you can simply plug in a value of x to determine what that constant is equal to. Now this is, of course, and once again, on some interval I. It doesn't necessarily have to be true for all real numbers. For example, let's say that we consider f of x is equal to the secant squared of x, and g of x is equal to the tangent squared of x. If I differentiate f, we'll be making use of the power rule as well as the chain rule. So starting with the square, that would be 2 times secant of x to the first power times the derivative of the secant of x, which is, of course, secant of x times tangent of x. Rearranging this ever so slightly and combining some factors, we get that this is 2 times the secant squared of x times the tangent of x. Additionally, if I were to differentiate g of x, the tangent squared of x, applying the same two rules for derivatives, that would be 2 times tangent of x to the first power times the derivative of the tangent of x, which would of course be the secant squared of x. Rearranging these ever so slightly, we would get the same derivative, 2 times the secant squared of x times the tangent of x. Now with that in mind, that means f of x is equal to g of x plus some constant. Or, a little more specifically, that would be that the secant squared of x is equal to the tangent squared of x plus some constant. As we did in the last video, we can plug in any value of x to determine what that constant is equal to. I'm going to pick my favorite angle one more time, plug in x equals 0. So that would give us the secant squared of 0 is equal to the tangent squared of 0 plus whatever that constant is. Secant of 0 is 1. 1 squared is 1. Tangent of 0 is 0. 0 squared is 0, allowing us to arrive at the conclusion that c is equal to 1. So what we have now shown is that the secant squared of x is equal to the tangent squared of x plus 1. This is the derivation of one of our 3 Pythagorean identities. These consequences can actually be used to prove all 3 of our Pythagorean identities. Once again, we don't necessarily have to use calculus, but this is kind of a neat way to do it. In fact, it's so neat that I'm going to put a little smiley face here. Yeah, smiley face.